We are starting a new chapter. This first section is called inverse functions. First thing we want to do is to be able to identify one-to-one functions. And by definition, we say that a function f is one-to-one if, whoop, it's orange. So a function f is one-to-one if, for elements a and b in the domain, if you pick different x values, so if a does not equal b, then f of a does not equal f of b. As long as you pick different x values, you get different y values. A big thing, I'm going to reemphasize that, the y values do not repeat. Remember that in order to have a function, the x values couldn't repeat. Now in order for the function to be one-to-one, the y values can't repeat. Let's go look at an example. Let f be the set of ordered pairs, and I gave you 5 ordered pairs there. Do you notice that the x's don't repeat? The x's, the domain is 2, -1, 0, 1, and 4. The x's don't repeat, so this is indeed a function. Do the y values repeat? The y values do not repeat either. So that makes this function a one-to-one function. Now we want to switch the x and y values and make a new function g. Well, 2, 2, you can't really tell those are swapped, but they are. What about -1, 1? It becomes 1, -1, 0, 0, 1, 3 becomes 3, 1, and 4, 5 becomes 5, 4. When we do that, when we swap the x and y's of a one-to-one function, we create what's called the inverse of f. So g is now the inverse of f. You just swap the x's and y's, exactly. Okay, the note there says f must be one-to-one in order to have an inverse function. So my question to you, will every function have an inverse? No. Only the one-to-one functions have an inverse. The function has to be one-to-one before you can have an inverse function. How do you find the inverse function? You're going to swap the x and y's. Exactly. Okay, number 2. Is the function f of x equals -4x plus 12, is that one-to-one? To show that algebraically, we need to show that f of a equals f of b implies that a equals b. In other words, if the y values are the same, then the x values have to be the same. Okay, what is f of a? Right here, what is f of a? Plug in a for x, what do you get? -4a plus 12, right? f of a is -4a plus 12. What is f of b? It's not a trick question. -4b plus 12. What happens if I subtract 12 from both sides? What's left? Now what happens if I divide both sides by -4? A equals b, right? So if I started out with 2 y values, f of a equal to f of b, I just showed that a had to be equal to b. That meets the condition of a function being 1 to 1. So yes, that function is 1 to 1. We're going to come back to the green part in just a second. Let's go look at number 3. Is y equals square root of 25 minus x squared 1 to 1? So again, let's start out with f of a equal to f of b. What is f of a? Root 25 minus a squared. And we want that equal to f of b, which is root 25 minus b squared. What if I square both sides? What happens to the square roots? They disappear, they cancel out. So I get 25 minus a squared equal to 25 minus b squared. I'm going to subtract 25, good. Negative a squared equals negative b squared. Divide both sides by negative 1. And I get a squared equals b squared. Now when I take the square root of both sides to solve for a, what happens in front of the square root on the right? I have a plus or minus. So I end up with a equals plus or minus b. What was I trying to show? A equals b. What did I show? A equals plus or minus b. It's not the same. It's not 1 to 1. Yeah. Why did I put the plus or minus? If you were to try to solve x squared equals 25, how do you do that? You take the square root of both sides, but what do you have to put in front of on the right-hand side? Plus or minus, so that you would end up with x equals plus or minus 5, right? Same concept. That's why the plus or minus goes in front of the square root of b squared. Okay, how many of you like showing that a function is 1 to 1 by doing it algebraically? Ugh. All right, there's an easier way to do it. It's called the horizontal line test. The horizontal line test says if any horizontal line intersects the graph more than once, then the function is not 1 to 1. Do y'all remember the vertical line test? If any vertical line intersected the graph more than once, then it was not a function. Horizontal line test says if any horizontal line intersects more than once, it's not 1 to 1.
Is that so that it has 2 points?
It has 2 different x values that have the same y value. So it would not be 1 to 1. Okay, back up to example number 3. Y equals the square root of 25 minus x squared. When I put that in on my calculator, this is the graph that I get. It's actually a semicircle. Okay, would that function, would that graph pass a vertical or a horizontal line test? If I drew this horizontal line, how many times would it intersect? Twice. Is that 1 to 1? No. Now, someone asked me, why is this half of a circle? I went over here, and if you square both sides, you get y squared equals, the square root goes away, right? I add x squared to both sides. I get x squared plus y squared equals 25. Do y'all remember that that's a circle centered at 0, 0 with radius 5? Do y'all remember the equation of a circle from way long ago? Y'all are going, yeah, no, Yeah, you're remembering something about pies. The area of a circle is pi r squared. Yeah. Anyway, you can always go graph that on your calculator. It's a semicircle. Okay, what are you taking away from this, from that green? Horizontal line test. If a horizontal line crosses more than once, it is not one-to-one. Going to do these examples. Number 4. First one. Would that pass the horizontal line test? Yes. Is it one-to-one? Yes, that one is one-to-one. The second one. It would not pass a horizontal line test. That horizontal line would cross it twice. It is not one-to-one. How about this third one? Is it one-to-one? No, it would not pass a horizontal line test. What about this one? Yes, it is one-to-one. What do you notice about the two one-to-one functions here? What are they always doing? They're always decreasing, right? Whereas this one that's not one-to-one is increasing, and then what does it do? It decreases. This one increases, then decreases. Or you can look at it another way and say it's decreasing and then increasing. What happens when you change from either increasing to decreasing or from decreasing to increasing? Is it going to pass a horizontal line test that way? No. So that next green thing says if a function is always increasing or always decreasing. If the function is either always increasing or always decreasing over its entire domain, then it is one-to-one. Back up to the other green. If f is linear, what does that mean? That means the graph of f is a line, right? This line is always what? Increasing or decreasing? That one's always increasing. This one would be always decreasing, right? Okay, as long as you don't have a horizontal line. If f is linear, f will be one-to-one. Linear functions pass the what test here? With the red. They pass the vertical line test, and they pass the horizontal line test. As long as the linear function is not horizontal. Vertical line test says that it is a function. Horizontal line test says it is a one-to-one function, right? Okay.